friends, welcome back to the channel, and in this video we are going to discuss introduction to decision tree algorithm, and we will know what is decision tree and how this algorithm works. So let's get started without wasting time. In the next slide, here we see the introduction. So, decision tree are the fundamental machine learning algorithms used both for classification and regression. In the next slide, we will learn what is classification and what is regression. So, here it is a versatile supervised machine learning algorithm. What is versatile supervised learning machine learning algorithm? So, if you don't know this, then please refer to the previous videos of this playlist, which is perspectives and issues in machine learning. In that video you will learn what is supervised machine learning, what is unsupervised machine learning, what is reinforcement machine learning algorithms. Okay, so now the next thing they say is they are easy to understand and are often serve as building blocks for more complex models. And in this introduction we will explore the basics of decision tree algorithm in machine learning. I hope you understood until this point. Let's go to the next slide. So, what is classification and regression? Classification, like whatever we see in real life, we give some classification to it. Now let's say here we have a example of email spam classification. That means whatever mail you get in your mailbox, they may be spam or they may not be spam. So we have two classifications, spam mails and not spam mails. In the same manner, we have another example, that is disease diagnosis. That means a patient may be diagnosed with disease or they may not be diagnosed. So that is two, we have two classification. I'll give you one more classification example. Let's say you have a banana in your house, and the banana may be rotten or it may not be rotten, right? Or it may be in the middle of that. So now you have three classifications: it is rotten, it is not rotten, and it is in the middle of those two stages, right? So that is classification. You can have two classification, you can have more than two classifications of a object. Okay, what is regression? House price prediction, or how house price prediction. So whenever you or your parents or anyone buys a land or a house, they see so many things, right? They consider the square yards, they consider in which area it is located, and they consider the price of neighboring lands or house also, right? So these all things come into the picture, and then the final price of the house is estimated. Okay, now crop yield estimation. Again, farmers are growing crops in their fields, so there also so many things come into picture, like quality of the land, soil, and how much seeds they have kept in the soil for growing, and what types of pesticides they have used. So all these small things come into picture, and then the total crop yield is estimated, right? And the next example is stock price prediction. So here also so many experts come, and they analyze the previous data, and they see that what is the previous data, and according to that what will be the next price of this stock, right? So they are doing predictions according to previous values existing in history. So that is regression. Now let's move on to the next slide. Here, a decision tree is a graphical representation of a decision making process. It is like a flow chart, and here each node represents a decision or a test on an attribute. So the first node represents the test on the attribute. That means we have so many attributes, we choose one attribute from the list, and then we examine it. Is the attribute less than or greater than, or is it satisfying any condition? So that is testing an attribute. The next node, which is the branch, it represents an outcome of the decision. That means if you test the first attribute, you get some result. So this one is the branch node, which is representing the result from the previous node. Now the leaf node are the least, I mean last node of the any decision tree. So these represents a class label or a value if it is a regression problem. So it will be a classification if the tree is a classification tree, or it will be a value if the tree is a regression tree. Okay. Now, what is regression tree and what is classification tree? So regression tree is the decision tree used for regression tasks, predicts a continuous value, for example numeric value for each instances, and each leaf node corresponds to a predicted value. So leaf nodes are giving some values, right? They are not giving classification. And in classification tree are used for classification tasks, assign classes, class labels to the instances, and each leaf node corresponds to a class label. So that is the difference between classification tree and regression tree. Now let's move on to the next slide. Here, how does a decision tree work? First is construction of tree. Second is recursive splitting. That means we are testing the nodes, right? After that we are getting some results, and after that again we are testing that, and again we are getting some results. In the last we are getting root node, I mean leaf nodes, right? Then we have decision rules, and also here we have some keynotes. I will explain you later. First let me explain this one. So the process begins with the selection of the best attribute from the data set. This attribute is used to split the data set into subsets. So the example of this decision tree you can find in the next video in the playlist. So you just follow the playlist, you will understand everything. So here we have a set of attributes, okay, and from those attributes we are choosing the best attribute, according to which we can split the graph more and more. So this attribute is used to split the data sets into subsets. So we will choose one attribute. Let's say, let's check if a person is eligible for a voter id card or not. So we have attributes like name, age, and their location. Okay, so what attribute will you choose to check if they are eligible for voting? Age, right? If they are greater than 18 or equal to 18, then only you will allow them to get the voter id card, right? So that is the best attribute chosen to split the data set, and the goal is to create subsets that are as pure as possible, meaning they contain instances of same class. That means like if you go on the right hand side, all of them should be of same class, and if you go on the left hand side, all of them should be of same class. So that is that should be considered. And in the second step, recursive splitting, so the tree building process continues recursively for each subset, creating sub-decision trees until a stopping criteria is met. So until you end up with the decision, until then the tree has to be splitted. And common stopping criteria include a maximum depth for the tree or the minimum number of instances per leaf. So that is the stopping criteria. The stopping criteria may be the maximum depth of the tree, or it may be a minimum number of instances per leaf. Okay, now the third one is decision rules. Once the tree is constructed, it can be used to make decisions. So to classify a new instance, you start at the root node and traverse the tree by following decision rules or attributes until you reach the leaf node with a class label or a regression value. So that label becomes the predicted class. So that is the last part. So whatever we got on the leaf node, that is our result. Now let's go to the next slide, keynotes. Here we have three things that we need to understand. It's not that important, but it's good to know. So entropy and information gain, these concepts are used to measure the purity of subsets, and they decide how to split the data optimally. Information gain quantifies the reduction in uncertainty, entropy, achieved by the split. So here entropy is used to measure the purity of the splitting of the data, that are we splitting the nodes with good attributes or not, or is it useful or not, or on the next node are we getting some good attributes to split the data further or not. So that is entropy. And information gain, it is to reduce the entropy. That means it is to reduce the chances of getting unpure let's say unpure splitting. Okay, Gini impurity, another measure of impurity used in classification trees. So this is also measure of impurity. It is used in classification trees. So it measures the probability of misclassifying an instance. So it makes sure that we do not misclassify any instances. So the next one is pruning. Here decision trees can grow very complex and overfit the training data. Pruning involves removing the branches of the tree to reduce the complexity and improve generalization. Here what we do is, if there are too many branches in the decision tree and it is becoming too much complex, then what we do is we remove some unnecessary branches and we make it more understandable and more, let's say, readable, or it will be more easy to learn it, right? So that is pruning. It makes sure that there is less complexity, and it is more generalized. And here, advantages of decision tree: it is easy to understand and interpret. It is suitable for both categorical and numerical data, so classification and regression. Now, it handles nonlinear relationships well. Also, it provides insights into feature importance. So these are the advantages. Limitations: here, prone to overfitting, especially with deep trees. If we have deep trees, that means those are too much complex and so much big. So that should not happen in decision trees. We cannot have deep trees. So also, it is sensitive to small changes in the data. If we do small changes in the beginning data, that means if we have the data set, if we do small changes in those, then the entire tree will be disturbed. Okay, so that should not be done. And also, they may not capture complex relationships as effectively as other algorithms. So these are the limitations. In summary, the decision tree algorithms are powerful tools in machine learning due to their simplicity and interpretability. They are often used as foundation for ensemble methods like random forest and gradient boosting, which aims to address some of the limitations of decision tree while retaining their strengths. So this is the overall summary for decision tree algorithm. And yeah, that's it for this video. I hope you understood whatever I have explained in this video. And if you did, then don't forget to subscribe to the channel and hit that like button. Also, press that bell icon so that you get notified whenever I upload a new video. Also, if you have any suggestions or questions, then you can put it down in the comment box. Thanks for watching. Bye bye.